Hi Geometry, welcome to So here we go. Some of this will be review. You've had a lot of these geometry parts in different math classes in the past, especially in elementary. And when you go through all of your math in the future, some of these words will become a lot more important. You'll be surprised, especially in calculus. All right, so here we go. What measure is needed to find the circumference of the or area of a circle? Okay, so remember what a circumference is. Circumference is your distance around. Do you remember that formula? It's actually derived in calculus is where they get it from. Circumference is equal to 2 pi times r. R is your radius. So it's the distance from the center to the edge. Alright, and then the area. Area is equal to pi r squared. So again, we need the radius. Now one thing I want to point out is the 2r. If you take two radii and put it together, you get something called the diameter. So you can use the diameter for circumference or the radius, and then definitely the radius for area. Okay? Alright, what's next? Find the radius of a circle with the diameter of 10 centimeters. So if the whole length is 10, what is the radius? 5 centimeters. A right triangle has the leg lengths of 5 and 12. Find the length of the hypotenuse. Alright, so you remember 5 squared plus 12 squared is equal to h squared. This does turn out to be a nice Pythagorean triple. When you work it out, h is 13. Alright, how about number 4? Let's solve. I'm going to subtract 15 on both sides. 6x is equal to 18. X is equal to 3. So far, so good? Keep checking. It's not as dark as I'd like it to. I've got a lot of the sunlight coming in today. It's rainy all day and it's really bright in my office. Go figure. Alright. Hey, let's solve this. Now, one thing you'll notice that this is squared. So that means I have to FOIL this out. Big mistake people make is they'll square the x, square the 18. They forget the outer and inner. So when you FOIL that out, you're going to have x squared plus outer is 18, inner is 18x. So that's 36x plus 18 squared is equal to x squared plus 24 squared. Now, in order to solve a quadratic, we have to get everything to one side. But what's going to happen when I subtract x squared? Those are gone. So now the only x I have is right here. I'm going to keep that on the left side. And then I'm going to subtract that 18 squared on both sides. Can you tell I've been kind of lazy to get my calculator? When I actually put that in the calculator, 36x is equal to 252. Divide both sides by 36. X equals 7. Don't be afraid to use this kind of notation. You don't have to use a calculator for every single step. You can wait till the very end. Alright, key concept. A circle is a set of all points in a plane that are equidistant, meaning the same distance. If this is the center of my circle, I'll put, like, usually they use the letter O for center. I'm not sure why. Equidistance. These are all the same distances. So every point on the edge of the circle to the center. Okay. A circle with center P is called circle P. And it can be written like this. A segment whose endpoints are the center and any point on the circle is called the radius. Okay, so that would be this segment right here. Here, I'll try to use the same colors that they used. That is the radius. Okay, a chord is a segment whose endpoints are on the circle. So they use a different blue. I wonder if I have a different blue here. Yes, I have a different blue. Let's use this one. This is our chord. The diameter is a chord that contains the center of the circle. So, right here in purple, I like colors. Whoa, crazy line. That's our diameter. A secant is a line that intersects in a circle at 2 points. That would be this one. It's hard to read. That's why I'm kind of going through this. This is our secant. And last but not least, your most famous one. This is so important. You have no idea how much you're going to be using this in the future. Tangent is a line that hits in one spot. Okay? So notice that tangent is a line, secant's a line. Everything else is a segment. So let's now use that information. Okay, you have to know these. Let's use that information to apply. So here we go. DE, that's from here to here. What is that called? It knows it's a segment. DE is called the radius. Can you see that? Okay, DC, segment DC right here. Now notice it's a segment, not a line. That would be a chord. Segment AD. It goes through the center. That would be your diameter. Ooh, line BA. Line BA, it touches the circle in one spot. That's your tangent. And last but not least, line BD. It hits the circle in 2 spots. That's your secant. So you definitely will see these 2 statements as trigonometric functions. They all relate. They really do. Okay, next page. Example 2. Here we go. Use the diagram to find the radius and diameter of both circles. All right, so it's kind of hard to read, but I'll help you out. So would you agree that this is the center of the little circle? Okay, so the small circle, the radius is from here to here, is 1/2. So that means the diameter will be twice that long, 1. Okay, so now the center for the whole circle, this is actually the center for the big circle. Can you even see that? Nope, can't really see it. Wonder why. Still can't see it. Maybe if I close these curtains. Oh, that helps. Get rid of the glare. Close the curtains a little bit. But it's so pretty outside. So a big circle. The radius is from here to here. That's a length of 1. And the diameter would be the full length is equal to 2. So that just reinforces that the radius is half the length of the diameter, or you can say the diameter is twice the length of the radius. Okay, moving on. I know it says vocabulary, but yours says coplanar circles. So circles in the same plane. Here, 2 circles have 2 points of intersection, right here and here. These are tangent circles, meaning they intersect only in one spot. If they have the same center, they're concentric circles. And here there are 2 different circles, but they are congruent because look at the radius is the same length here and here. So check this out. Line L and L1 and L2 have common tangents. So are common tangents right there. Example 3. Now, tell me how many common tangents the circles have and draw them, okay? Let's see here. With this picture, you can draw a tangent line like, let me use a ruler here. No good's coming out of this. Or a straight edge. There's one tangent line. And there's another tangent line. They're hitting each circle. So a tangent line that hits each circle once. So this picture would have 3 tangent lines. How about this one? Well, we know it has the 2 outside ones. Let's draw those. So there's 2 right there. And check this out. I can draw a line right here. It hits each circle in just one spot. And I can also do it this way, so it kind of makes a crisscross. Alright, I should be putting dots at all the tangents. It's kind of cool looking, isn't it? Alright, this one actually has 4 tangent lines. And how about this circle? There's only one spot, right here. One tangent. Alright, well keep in mind, tangent will hit the circle or a curve in the future in one spot. Alright, theorem 10.1. Where is this all going? Now, what's interesting is, in a plane, a line is tangent to the circle if and only if there's a line perpendicular to a radius of the circle at that endpoint. So, at every single tangent line, you can draw a radius that will make a right angle. Okay? Obviously, we can use that in pictures like this, because now you have a right triangle. See why we did the right triangles prior to this? So, in the diagram, BO is the radius from here to here. Okay, so that means this part is 9 also. And BA is a tangent line. So what is the length of OA? So I need this whole length. Well, I have a right triangle, don't I? 9 is a leg, 12 is a leg, so this will be the hypotenuse. 9 squared plus 12 squared is equal to, we'll call that H for the whole hypotenuse, H squared. So 81 plus 144. And when I add those up, 225. H is equal to 15. Now that's this whole length, okay? But I should notate it. But what if I wanted just this part? 'Cause sometimes you will have that part or you'll be asked that part. If this whole length is 15, that part's 9, this has to be 6. Okay? They didn't ask that, but anyway, moving on. But it does relate to this one. So find the length of the radius. Well, I know it's a tangent line, so this must be a right angle. Okay? You have this segment. You know that's a radius of the circle, and that's also a radius of the circle, because remember, radii are equidistant from the center to the edge of the circle. So those are both x. So how we solve this is, I have x squared plus 48 squared is equal to the hypotenuse, which is x plus 36 squared. Alright, so far so good. You're going to see why we did a certain problem in our warm-up. Alright, I need to FOIL this. So don't just square the x and the 36, that'd be bad. You need outer and inner also. So x squared plus 48 squared is equal to, when I FOIL this, x squared plus the outer's 36x, inner's 36x. Add them up, you get 72x, and plus 36 squared. And again, I still don't have the calculator out, but I will. What's going to happen to these x squareds? They both cancel. And I'll have 48 squared is equal to 72x plus 36 squared. Let's subtract that on both sides. So 48 squared minus 36 squared is equal to 72x. Divide both sides by 72. You'll have your answer. So now I will finally take out my calculator and give it a 14. So the radius of the circle is a 14. Cool, huh? I think so. Theorem 10.2. Tangent segments from a common external point, like right here, are congruent. So I have two tangents, A and B. This segment is going to be congruent to that segment. And also you'll know you'll have two triangles with a common hypotenuse. And look at that. Right triangle, hypotenuse leg. Oh, you have two similar right triangles. How cool is that? Okay, and it's by hypotenuse leg. Please don't use angle side side. It's a right triangle, so hypotenuse leg. That might come up in the future. Last page, and then we're done. So this is a nice short video, and it looks like we're still recording. That's good. I hate when I have to do these like 5 times. Happens a lot. All right, let's see here. Circle O, PQ is a tangent line at Q, and then PR is also a tangent line at R. Find X. Well, these two are congruent. So if they're congruent, just set them equal to each other. 25 is equal to 6x minus 8. I want to add 8 to both sides. 6x is equal to 25 plus 8 is 33. Divide by 6. And it just gives you some weird number. I wish it worked out nicely, but you know what? You're going to have decimals. Life is good. Okay, 6 times 5 is 30. This is going to be what? 5.5? So, but don't be afraid of those. Alright, here's our homework. Notice number 34, good luck. I like doing that. And here's our Common Core Standard. Have a nice evening, stay dry, and hopefully I'll get all of Chapter 10 done this weekend. High hopes, huh? Take care.